Okay, so this is a video for objective 5.4. Specifically, we're going to be talking about just basic multi-step problems. So these are the multi-step trig equations where we don't have to factor or use the quadratic formula, for example, or any trig identities most of the time. In our review, this is what we referred to as problem type B. There are an assortment of different problems that kind of fall under this category. We're going to try to do a couple of the more standout problems that we've encountered. If you are having trouble with just basically solving for theta once you get it simplified down to your trig function, I recommend going back and watching the video for problem type A first, as this is something that is a little more complicated than those. So this video assumes that you are good at solving for theta. So let's look at just problem number 1 first. So 2 cosine theta minus 1 equals 0. Now the key to each type of problem that it falls into this category is you first need to isolate your trig function, which in this case is cosine theta. To do that, you basically just need to pretend that you are solving an equation with a variable. So instead of cosine theta, what would you do if there was an x here? So if it was just an x, we would want to add 1 and then divide by 2. So for this problem, we're going to add 1. 2 cosine theta equals 1, and then divide by 2. So cosine theta equals 1/2. Now, if you remember your unit circle really well, you can probably figure out what this is going to be, but just in case you haven't, remember when we talk about cosine theta equaling 1/2, that means that our x value is going to be 1/2, and I want to know what 2 points on my unit circle produce that x value. So if you don't remember your unit circle at this point, you're going to say inverse cosine of 1 divided by 2, or 0.5, and you get 60 degrees, which you may have remembered. So one of your angles will be 60 degrees. Now the way we solve these problems is, of course, still dependent upon whether I want theta between 360 degrees and 0, or if I want all values of theta. And hopefully you've figured out the difference by now. If we're solving for one revolution between 0 and 360 degrees, then obviously 60 is one of them. And then the other one is going to have to be down here. If you go all the way around and stop at that point, you should get 300 degrees, which also you may remember from memorizing your unit circle. The difference, if I am solving for all theta, still just means that we need to add 360k. So that's a pretty straightforward one, but it is important to know the steps. And of course, as always, if you're not sure if these are correct, you could always take these answers, plug them back in here for theta, do 2 cosine times 60, or 2 cosine of 60 minus 1, and then 2 cosine of 300 minus 1. See if they both give you 0. So that is one way to check your work. Okay, let's look at problem number 2. Square root of 3 secant theta plus 2. Now this is a type of problem, it should be equal to 0, I'm sorry I didn't write that before. This is the type of problem where I see a lot of students get stuck because this square root of 3 intimidates some people. Don't let it. Remember, square root of 3 is just a number. In fact, if it really bothers you, you can always just figure out what is square root of 3, and it's 1.73. So if I were to rewrite this problem as 1.73 secant theta plus 2 equals 0, well, it's got a decimal now, and it's not a very exact decimal, so my answer is going to be rounded a little bit too much. But this is hopefully a little less intimidating. So if nothing else, you can always go back and do that. For the purposes of this video, I am going to solve this with the radical because I want you to get in the habit of doing that. It will make the answer a little more obvious. So I'm going to ignore that for now. First, we will subtract the 2. So that gives me square root of 3 secant theta equals negative 2. And then to get rid of this is multiplication. Square root of 3 times secant. To undo multiplication, we divide. So secant theta equals -2 over square root of 3. Normally, we would rationalize our denominator, but because this is secant, and we don't have an inverse secant button, we're going to change that to 1 over cosine theta, which is -2 over square root of 3. And when we take the reciprocal of this side, we also take the reciprocal of the right side, and we get cosine theta equals negative square root of 3 over 2. It doesn't matter if I put the negative on the top or the bottom, because if it's one of them is negative, the whole thing ends up being negative. To get our inverse theta, or inverse cosine, we're just going to use our calculator or our knowledge of the unit circle. But in case you've forgotten the unit circle, you can always rely on your calculator, and it will tell you one of the answers. So that is negative square root of 3 divided by 2. Watch your parentheses. Notice that I closed the parentheses after the square root before I divided by 2. Compare that to if I had done negative square root of 3 divided by 2. Notice now I'm taking the square root of 3 over 2. This is not going to give me the same answer. So if you got a domain error on this problem, that means you typed something in your calculator wrong. Be extra careful about that. Always use more parentheses than you think you might need. But the one that actually worked gave me 150. So theta is 150 degrees, which you may have remembered. That is in quadrant 2. And because this is a cosine problem, the other one will have to occur in quadrant 3, which is a reflection over the x-axis, which means this is also 150 degrees. So my second angle will be 360 degrees minus 150 degrees. Now, of course, we have to figure out, are we solving for all angles that are between theta, or 360 degrees, or for all theta? The problem will typically tell you, but if you don't realize which one you're doing at the beginning, as long as you remember which one you're trying to figure out by the end, you should be okay. So I would still figure out these two angles. Of course, this one is 210. If I want angles between 0 and 360, I will just say it's 150 and 210. Notice I get two answers. For all theta, it will just be 150 plus 360k, and 210 plus 360k. And don't forget, if you're not sure, you can check your work by plugging those back into theta at the beginning. All right, one more. And this is one that I see a very common mistake made every time we do them, so be careful. Tangent squared theta minus 7 equals 0. Now it's going to start out the same. We will add 7 to both sides to get our trig function by itself. So that gives us tangent squared theta equals 7. And now many of you correctly recognize that taking the square root of tangent squared and the square root of 7 will get rid of that square, and it does. But the thing that sometimes people forget, and don't be one of them, is that whenever you take a square root when you're solving an equation, you must put a plus or a minus in front of them. For example, remember that square root of 4 traditionally we think of as being 2. But if I were to say that, well, this would imply that 2 squared gives me 4, but we of course know that's not the only thing that gives us 4. I could also do negative 2 squared and get 4. So square root of 4 technically could be thought of as plus or minus 2. And if we're solving an equation, we have to take all possible solutions into account. And that negative part is also a possible solution. So at this point, we really have two different problems. Tangent theta can equal square root of 7, or tangent theta can equal negative square root of 7. Now, typically, each one of these would give us two answers, so this problem is probably going to have 4 potential answers between 0 and 360 degrees. So don't let that scare you off. It will happen from time to time. You should keep an eye out for it. Now, if we just take our inverse tangent, then we will get our first answer for square root of 7 as 69 points, roughly 30 if we round. Now, because it's tangent, to get the other one, we just add 180 degrees. So it will also occur at 249.3 degrees. Now for this one, we're going to do inverse tangent of negative square root of 7, which is going to tell us negative 69.3 degrees. But we don't want the negative version, typically, anyway. So we need to figure out what that is in the positive direction. One way you can do it is just to add 180 degrees, because you know that this will repeat right here. Or you can calculate what this is. That's 69.3 degrees. So to get this angle, you can just say 360 minus 69.3 degrees. A couple different ways you can do it. Regardless, hopefully you're going to figure out that this angle is actually 290.7, and that the other angle in quadrant 2 is 110.7. I don't care how you get there, but we need to figure out that this negative angle actually refers to these two angles when we are discussing the theta that is between 0 degrees and 360 degrees. So for those, we have four answers: 69.3, 249.3, 110.7, and 290.7. Those are the four that are in one rotation. And for all theta, remember that when we talk about tangent, you can just write them all and put plus 360k, plus 360k, plus 360k, plus 360k. But to save ourselves some time, I only need to take one of each of these, because this one plus 180 gives that one, and this one plus 180 gives that. I can just say 69.30 degrees plus 180 degrees k, and theta equals, let's take this one. I could have used any of these three, but I'm going to take this one because I like the positive angles. Plus 180k. Remember, this is the second option for the tangent problems. You could also just add 360k to each one of these. Personally, I prefer this one, but if you add 360k to each one of those, it is correct. It won't count against you on a test or quiz.